Welcome to this explainer. Look, if you've ever stared at Google Cloud's massive menu of computing options and felt totally overwhelmed about making the absolute right architectural choice, you are definitely not alone. Today, we're going to translate all that complexity into a super simple, practical mental model. We'll unpack your options, weigh the trade-offs, and get you set up for success. Here's how we're breaking it down today. First, control versus management overhead. Next up, virtual machines and compute. Then, containers with Kubernetes and run. After that, we'll hit App Engine and cloud functions. And finally, we'll wrap up by testing your knowledge with some real-world cloud scenarios. All right, kicking things off with part one, control versus management overhead. This is the core philosophy that should drive every cloud decision you make. Here is the golden thread for everything we're talking about today. Your ultimate goal when picking a computing platform is to meet your technical needs while keeping DevOps overhead and costs as low as possible. It's really a sliding scale. Over on the far left, you've got Compute Engine, giving you maximum control. But hey, that means maximum management responsibility for you. In the middle, platforms like Kubernetes Engine and App Engine give you a nice balance, handling a lot of the heavy lifting. And all the way on the right, that's your incredibly low overhead serverless stuff like Cloud Run and Cloud Functions. A great rule of thumb? Whenever you're building a solution, try to push your workload as far to the right of this spectrum as your technical limits will actually allow. Moving right into part two, virtual machines and compute, starting at the highest level of responsibility with Compute Engine. So, virtual machines aren't just floating out in the ether. They exist within a very strict hierarchy in Google Cloud. When you spin up a Compute Engine instance, you have to tell it exactly where to live. First, it needs a project, which is literally the lowest level of the resource hierarchy. Then, you define the region, think of a broad geographic spot like US East 4, and finally, you pick the specific zone right inside that region where the VM will physically run. Nailing this hierarchy down is absolutely crucial for managing your resources and, of course, keeping latency super low for your users. Now, if you're living in Compute Engine land, you have got to know about preemptible VMs. Here's the deal. They will absolutely terminate within 24 hours, no exceptions. Google doesn't guarantee their availability, but the trade-off is massive cost savings. They're a total game changer for workloads that don't mind getting interrupted, like a batch processing job without a strict deadline, or high-performance computing where work can just bounce to another node. But if you try to use a preemptible VM for something needing constant uptime, like a production database server, yeah, you are pretty much guaranteeing a disaster. Also, because Compute Engine puts you on the far left of our control spectrum, you are managing the operating system yourself. And that means security is squarely on your shoulders. This is where features like VTPM become a total lifesaver. By turning on VTPM for your instances, it actively verifies the boot integrity of the machine. It ensures that nasty stuff like rootkits or malicious software hasn't secretly compromised your OS before it even finishes spinning up. Let's slide on over toward more convenience with part three, containers, specifically focusing on Kubernetes Engine and Cloud Run. These days, modern software is usually just a bunch of microservices running on totally different life cycles. Kubernetes Engine takes a massive chunk of that management headache off your plate. It automatically handles load balancing across your VMs, scales your nodes, checks node health, and even upgrades cluster software for you. It's awesome. But remember our spectrum. You still have some responsibilities here. For example, Kubernetes does not natively scan for security vulnerabilities. For that, you'll still need to wire up a separate tool, like Web Security Scanner. But what happens if your company grows so much that you're suddenly running multiple Kubernetes clusters, maybe even spilling over into AWS or your own on-prem data centers? Well, that's exactly where Anthos steps in. Anthos becomes your central command center, a fully managed service for administering all those clusters together seamlessly. Pair it with Anthos Service Mesh, and you've got consistent security, auth, and monitoring across your entire crazy complex infrastructure. But what if you have a containerized app and you really just don't need the heavy-duty features of Kubernetes Engine? You just want less overhead. Cloud Run is fantastic for this, but there is a catch. Your application absolutely must use stateless containers. If your app relies on storing session data in memory to remember user across multiple requests, Cloud Run is completely off the table. It is built for quick, stateless execution, plain and simple. All right, diving into part four. App Engine and Cloud Functions. This is the highly managed serverless end of the pool.
Inside App Engine, which is phenomenal for HTTP web apps, you have a major fork in the road, standard versus flexible environments. The standard environment is all about maximum convenience. It runs specific language sandboxes, think Python, Java, Go, and it can literally scale all the way down to 0 instances when traffic stops, saving you serious money. The flexible environment, though, hands you back a little bit of control. You get to bring your own custom Docker files, which is actually mandatory if you're trying to run an unsupported language like C.
Pushing all the way to the extreme right of our convenience spectrum, we hit Cloud Functions. These are built for loosely coupled apps that react to events. Think of them as the ultimate glue code. An image gets uploaded or a message hits a queue, and boom, a Cloud Function wakes up, does its very specific job in a secure, isolated runtime, and goes right back to sleep. And the absolute best part? You never have to worry about managing threads or separate processes. Google Cloud guarantees those function invocations won't trip over each other. Okay, let's bring it all together in part 5, real-world cloud scenarios. Let's test that mental model we've been building. Scenario 1. Let's say you've got a Python web app. It just uses custom code and basic libraries. Usage is going to be incredibly sporadic, and your boss wants you to aggressively minimize both the hosting costs and the DevOps overhead. So where does this workload belong? Keep our spectrum in mind. We need extreme convenience, huge cost control, and we're using a supported language. The perfect fit here is the App Engine standard environment. Since it's Python, it drops right into the standard sandbox. And because traffic is sporadic, standard's superpower of scaling down to 0 instances means you won't pay a single cent for idle servers. Trying to use Compute Engine or Kubernetes for this would just drown you in totally unnecessary configuration overhead. Scenario 2. You are running an online service made up of several distinct microservices. You've got one set for the UI, a completely separate set handling authentication, and a third set for account info. All of them need to be bulletproof, highly reliable, and they have to scale independently to handle heavy demand. This is where Kubernetes Engine absolutely thrives. You can easily deploy each of these service groups into their own isolated pods. Then you just let Kubernetes do what it does best, automatically handling node health, load balancing across all those distinct VMs, and seamlessly scaling up when demand spikes. App Engine Standard just wouldn't give you enough structural control for these distinct groups, and doing it manually on Compute Engine, that's a massive DevOps nightmare. Final scenario. You've got a mobile app that lets users upload images straight to cloud storage, and a back-end service that analyzes those images. You want these two things completely decoupled, but the analysis needs to happen the split second an image lands. And crucially, you refuse to pay for a server that just sits there twiddling its thumbs watching a storage bucket all day. This is the textbook definition of event-driven glue code. By using Cloud Functions, you just write a quick Python script. The instant a file hits cloud storage, it triggers the function. The function grabs the URL, hands it off to your analysis service, and shuts down. No continuous servers running. The mobile app and the back end stay totally independent. It's an elegant, incredibly cheap solution that requires basically 0 maintenance. So as we wrap up this explainer, I really want you to start looking at every new project crossing your desk through this lens. Challenge yourself. Are you just defaulting to heavy VM-based infrastructure because it feels familiar? Or can you slide further to the right, embracing containers and serverless to finally shed all that unnecessary DevOps weight? Because at the end of the day, the perfect architecture isn't about hoarding the most control. It's about taking on exactly the amount of control your workload actually demands and happily outsourcing the rest. So where on the spectrum does your next workload truly belong?